more games and then with
Okay, perfect. So are we ready for the part two?
I'm going to open the data file.
Oh yeah, I still have to open up two. Class survey.
Good night. Thanks. It was pretty epic. We about to do.
Hey, what was that website that you gave me, Victoria? It was the statistics.byui math, right?
Yeah, I have it up here. Yeah, statistics.byuimath.com.
Oh.
And then I have like /index.
Oh, okay, cool. That's what I had.
Okay.
Awesome. Found it. Okay. And we have so I will go ahead and
When we label pie chart in line 1 and line 2, is that how you label it? Anybody there yet? Because it's telling me to label it.
Because I know I just took it straight from there.
Did you? Okay. So we're just defining slices by rank, right? That's what we're doing.
Yeah.
Okay, that's all, because it says label it, but I'm wondering if you have to go to titles and put something, or I don't know.
I think in the what do you call it? The key, they had little things on there, but they never said how to label them in the SPSS or in the book. So I'm trying to remember, because I think we did learn it at some point.
I don't remember learning that. Okay.
I don't know.
Okay, so now we're supposed to cut and paste it. All right.
Yeah.
Copy paste it.
Okay. Yeah, I just copied and pasted mine. I don't see exactly how to add labels.
I was going to play around with it and see if you go to titles, it can do anything there.
Yeah. That didn't work.
Hey Victoria, when you did you do summaries of groups of cases, or summaries of separate variables, values of individual cases?
For number 8?
Or number 6? Actually, never mind.
Okay.
When you did divide, wait, hold on, let me see.
I like that a lot better when you put the title on it. It looks better.
Oh, did you just do like the add new title thing?
Yeah. And I just put class
Okay.
survey by rank, and
Okay.
then therefore I know what that little legend is with the different colors.
Yeah.
Just makes it better, I think.
Okay. Yeah, I clicked on like the other one next to it, and it didn't really do what I wanted. So.
All right. Are
So
we
when
on
you
number 7?
no, so when you put like what do you have to put into the define slices by? Is it class time?
Rank.
No.
They
Class.
say by rank, yeah.
Okay. And
So.
then
See, now that makes sense to me because I put the title. It also titles the legend of the little color. So before I'm like, it didn't dawn on me that FR means freshman, JR means junior, and SR means sophomore, and SR means senior. I'm like, oh, now I get it. Duh.
Oh, I couldn't figure out what SO was for the longest time. I was just like, what's that supposed to be? Senior officer? Like, I was so confused. I was just like, I'll just let them be.
Cool. Yeah, so I did that one. Perfect.
We just do simple, right, for the bar chart?
Yeah, it wants you to
Bar
keep
graph?
it at the default, so simple and
Okay.
whatever the first bullet is, the summaries, whatever.
Okay. And then it says class rank again. So rank is the category access, I guess.
Yeah.
Title.
Okay. Perfect. So then are we on number 8?
Yeah.
Yep, I am.
Okay.
5 descriptors, huh? That's not the same
So then just
as summary.
describe like 5 describe do
I didn't even
I
read
think,
what the data was for. Like, okay. Uh,
like, I guess it's just
what
you're
is
wanting the class rank. I just started putting like the most amount of students or whatever are in this class, and the class with the least amount of people is this, and yeah, I just started just describing it
okay?
from what I saw, I guess. So
Sophomore has the most student
yeah,
body, yes.
what's the blue?
the blue is like there are blanks in the data. I don't know why, but there are.
Oh. So then freshmen are the smallest, I guess you would say.
Yeah, I think I wasn't thinking about it being freshman junior, so I was just like the least amount is in no class rank.
Oh, okay.
They're just like chilling out. I don't even know. They just come to the school and sit in classes. I don't know. Maybe they're like super seniors.
Yeah, maybe.
It's like
So,
don't
do
get
you understand what the data is for, though? I mean, I still don't understand. Are we measuring grades? Oh, is number 9 telling us what it's for? It's for cell phones. Okay.
I
Is that
think
what it's for?
nine's for something different. They're just
Oh, it is?
this section is about categorical. So
Okay.
it's not like you're gonna compute anything
Right.
with their grades or what you're figuring out. You're just figuring out what is like the proportion of people that are in these ranks.
Okay.
So categorical, this one at least deals more with proportion.
What else? 4 more things I have to describe about it. Okay.
Put what the most is, what the least is. Think I put like, well, this one has the most students. It's still less than half of all the students or something.
Okay.
Because the sophomores don't equal half; they equal less than half. And then, like the juniors account for, juniors account for for about a fourth of the students. Kind of, it's a little bit more, but yeah, I just started saying stuff like that.
Okay.
You guys ready for number 9?
Yeah.
Okay, so we need to use one of our new formulas that we learned in the textbook. I'm assuming.
Correct.
Yeah.
Okay, so A is saying what is the mean and the standard deviation. So do we do the p-hat?
Yeah, so it's asking the mean of p hat.
So is p-hat equals x over n, and we solve for p-hat then, or no, solve for x.
So p hat, I kept calling it p caret earlier.
I know, me too.
P hat.
Now I know it says p-hat. Like, oh, that's what you call it. Okay.
Yeah, so p hat is x over n, but your mean of p hat is p.
Oh, that's
without
right.
Any special stuff.
Right.
I think under like the sampling distribution of the sample proportion in the book, there's a little thing that says mean and standard deviation. That's what it gives you.
So the mean is just 7%? Or do we have to do that in a decimal form?
I put it in a decimal form.
Yeah.
But it's the same thing. I think it'll be easier to calculate, though, with the decimal.
Yeah. Oh, yeah.
Okay, so just what it means, mean of p hat equals p, that's just, let me get to the question. Oh, where did it go? Okay.
Standard deviation.
So 7% is p, so then the mean would just be 7%, right? The mean of p hat.
Yeah.
Mm-hmm. Yeah.
Yes.
0.07, yeah.
So the true population mean of p hat. So the mean of p hat is p. So I don't know if that helps explain it more, but. Yeah, because p hat just means your proportion. So you're saying like the mean of your proportion is this is your letter that you're categorizing it by, kind of.
Mm-hmm.
Okay.
Kind of like your mean of sample means is the like X bar, or your true population mean is the U. So it's saying the mean of the proportion is P.
So is N 750, right? Around the sample?
Yeah.
All right.
At least I think so. My numbers are all off by like 0.02
Oh, really?
compared to the thing. So I'll try again. We'll see if I can get it right this time. I think I'm doing it right, though.
We should do whatever's in parentheses first. The ones with minus 0.07.
What did I do? Hey, did you set it up like all in the square root of 0.07 times 1 minus 0.07 over 750?
Yes.
Uh-huh.
Maybe I just did mine wrong.
What did you
Did I
get?
set? I got 0.0034. So I think I just did my operations wrong.
Okay.
I must have, because it can't be that far off.
Yeah. I keep doing mine. I keep getting the same thing I was putting. And I don't know what I'm doing wrong. So, the equation is... Okay. So, the equation is...
Oh, sorry.
Go ahead.
Did you get 0.0093?
Yeah.
Yeah, that's what I got too. So I just wondered, what did I do that first time?
Did you...
It looks the exact same.
I don't know. Math is weird
What
that
did you
way.
guys get? I had 0.0352. Is that what you got too? Nope. Okay.
No, I got 0.0093.
93. What is the answer? Let me look at it.
It
Yeah, it
says
was 0.099. 0099.
0.099?
0.0099. So I don't know.
I feel like they must be off.
Yeah, because I feel like we have caught them a couple times when they've been off. So
Yeah. Because I've done it separately, like with each thing, and got that, and I've done it all together with a bunch of parentheses, and I still got that. So I don't know.
Yeah, so I think they must have just done something wrong.
Alright.
So, yeah.
So, just so I can compare my answer again, what did you guys both get?
We both got 0.0093.
9.3. Okay.
I'll be right back. I'm just going to get a drink. Okay.
Okay. So B? Are we going on to B or?
Yeah. Okay, so state the problem in terms of variable p hat.
So
Um,
that confused me at first. I think I got it now, but yeah. So I put like, you know how they had like P of X, so like the probability of this happening,
mhm.
and so I did like the P of P hat is greater than 0.08, because they're asking what is the probability that more than 60 phone users, 8% in the survey, use only cell phones. Does that seem right?
So p hat is
Like an estimator.
7%, correct?
Is what now?
No, sorry. P hat is the 0.0093.
That's the standard deviation of P hat.
Oh, yes.
Yeah. So the mean of P hat is P, and the standard deviation of P hat is the 0.0093.
Okay. So state the problem in terms of variable.
Yeah, so I think that one is like your P of X. So you're asking like what is the probability of this happening? So we're asking for what is the probability that this portion happens. So
Okay.
it's saying P of that P hat is greater than 0.08.
Oh, gotcha. That makes sense.
Yeah, so it's just like your probability of your proportion.
Gotcha.
And they want this proportion specifically.
Yeah, that makes sense. Okay.
Or they want more than this portion, so it's going to be like a equal, greater than, less than situation.
Okay. Yeah, that makes sense.
Yeah, because it confused me at first. Cause I was sitting there and I was like, what do you even mean?
So how would you state that then?
So you put, you know how you'd have p of x, so the p
Right.
with x in parentheses?
Mm-hmm.
So your x is whatever is supposed to happen, so we're doing the probability of the proportion.
Right.
So you're doing p, and then in parentheses,
You that.
p hat
Mm.
is greater than 0.08.
Okay. Oh, okay. Thank you.
Mm-hmm.
Draw a picture, the normal curve, and shade the desired area.
So I didn't draw anything. I just kind of did it in my head, I guess. But
it's the normal distribution, right?
yeah.
Bell shape, wouldn't it?
Yeah.
Yes. So you just draw like the normal curve, so the bell curve, and then it's saying like what proportion is greater than 0.08. So you draw a line for wherever that is, and then greater than. So you shade to the right of it. And because that's kind of like wherever your z-score is going to be, but they're not asking for that until the next question. So.
Okay. So we just go on to the probability applet then?
Yeah. Well, once you get your z-score, but it's just kind of, I think it's just trying to get you to think about it. Okay.
Your pajamas on your bed. Oh. So we're doing z equals x minus u over sigma divided by our square root of n. Is that what we're doing?
No.
No.
This
We don't need
one's
that one.
different. So this one, your value is going to be p hat, so the proportion.
Okay.
So, and your mean is still p.
Okay.
So you're doing the value minus the mean over the standard deviation, but you're using these proportions or whatever. So you're doing the p hat minus p over all of that over the square root of p times 1 minus p over n.
P minus, 1 minus p over n.
Yeah.
So you're taking the standard deviation formula, kind of.
Yeah.
Yeah.
Yeah, so you're just doing z is value minus mean over standard deviation.
So then what did you, so for the p hat, is that just the,
That's your proportion. So your proportion, you want it to be the 0.08 because you're measuring whatever is greater than that.
Okay.
0.08 minus 0.07 over 0.0093?
Yeah.
I'm sorry, you just stated how we setting it up. So it's 0.08 minus, what is our p? 0.07.
All over the standard deviation, which was the 0.0093.
What?
So the back in A,
Right.
where we got the
Three
mean and standard deviation.
Which I still didn't get the right answer, but.
Oh.
Okay, so I'm going to repeat how I have it set up on my work paper here, my paper. 0.08 minus 0.07, and then the denominator is the same thing as the standard deviation setup. So 0.07 minus parentheses 1 minus 0.7 parentheses over 750, and that's all in the square root.
It's 0.07 times 1 minus 0.07.
Times. Okay, that's probably what my
Yeah.
error is. Subtraction.
Yeah.
How did I get the
Yeah.
subtraction? How did I get that?
Probably heard subtract or something when we said it earlier
Yeah,
and
I'm
wrote it
looking at
down.
the writing. Yeah. Silly. Okay. That's probably when I get in the answer.
Yeah.
Yeah.
Yeah, so just multiply, but everything else was fine.
Okay.
That should get you the right answer.
Go back to order of operations. So everything in the parentheses first. Okay.
So 1 minus 0.07.
0.93.
Yep. And then
Yeah.
times 0.07.
Yeah. Okay. And that's 0.0651.
Uh-huh.
750. Okay, and then the square root of that, which of course it tells me it's the wrong format. I have to put the square root in first, the symbol. Okay.
Yeah. Yeah, I wish there was like an easier button to be like, this is the thing I want to square root.
Right. I don't have a memory button on mine, this calculator, so I don't know if that would help at all. But
Yeah, I don't know. I've never used it. I've just had to go back and put it all in.
mm-hmm. Okay. So that part alone, I finally got the same answer you guys got, 0.0093. Okay.
Okay.
All right.
And then you can use that in D to get your z-score.
Okay, so the final answer for 9D is 1.075.
Yeah, I think I put 4, but
Did you put 4?
I put 4, but it could have been the other way. Let me calculate it real quick.
Okay, let me plug that into the applet. Okay.
Oh, there I got 0.75. I wonder where I got why I did 4 earlier.
I'm not sure either.
It's something weird.
Hello, briefly.
Now I feel like I'm even more wrong, even though it's right. Because now what I had before it made it so I was like 2 points off, and now it's like 2 more points off. Like, okay.
Okay, so we're just shading the right tail, correct? Because it's
Yeah.
greater, right?
Yep. Just
So
graded
the probability is 0.1412 or 141. Yeah.
Yep.
Okay.
So interpret.
Yeah, I just said, what did I put? I just said there's like yeah, 0.141% chance that more than 60 phone users only use cell phones. Is that correct?
Yeah, that's what I put.
Instead of percent, wouldn't it be chance?
Yeah, that's what I saw in the other ones.
How do they
Oh,
word it?
cool.
Chance?
Yeah, I think I put it like there is a chance of 0.141 that
Okay.
more than 60 phone users only use cell phones.
Okay.
Okay. So are we ready to take the quiz?
So,
I think so, yeah.
Okay, perfect. Hey, I think this one should be an easy one.
hope I
Cool.
don't like throw a curveball at us.
Yeah.
I think we'll be okay.
So number 3 is in a pie chart. Why are the slices or sectors different sizes? Pies are- which size represents a category?
I'm catching up here. Hold on.
Oh, okay.
Okay. I'm there now. Okay.
You're
Is it
there?
in the second choice? I'm there. I'm here.
Okay, perfect. Yeah, so I got the second one. Like each slice represents a category.
Right.
Yeah,
Saw that in the ranks, and each one represents the different ranks. So that'd be a categories.
yeah, I think that's right.
Cool.
All
That's,
right.
and then number 4 is how are bar charts in Pareto? Pareto? How do you say that?
I don't know.
Parade. I don't know. I've been here.
Paredo's
Well,
fine. Mhm.
It's the third choice.
the only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest going from left to right.
Yes. It's the only difference.
Yeah.
So we Number 5. We conclude that p hat is normally distributed if np is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. Is p the true proportion or the sample proportion or the sample?
I'd say true, because it was saying the true population mean before.
Because isn't p hat represent like just a random sample of, or
P hat
what?
is the proportion. So I have true population mean of p hat. So mean of p hat equals p.
Okay, so mean p hat.
What I got?
Equals P. So it's true proportion. Okay.
For a little bit.
So 6, I would say sample size. But I know.
Yeah. Is it
Yeah.
2 or 2 specific something?
No, I think it's just sample size. Candidates in an election is a specific, like, example.
Right.
Whatnot. So I was just thinking, because there's one that had, like, X, the proportion of, like, the X over N, and the X was, like, the number of individuals with the characteristic.
Right.
Yeah, so, but N is sample size. That's what I'd say.
All right, number 7.
Alright, so sorry, my like video cut out for a little bit. Did you get true proportion for number 5?
Yeah.
And then 6, the sample size?
Yeah.
Okay. Alright, so then if p equals 1/4, what is the smallest n that satisfies the requirement?
Isn't it 10? Isn't this because it's the same as following the central limit or theorem, isn't it, or something like that? I'm trying to remember what my note said. And then like, if the sample size is large, the sample proportion of p hat will be approximately normally distributed. So does that have to do with it?
So.
And then we 30 actually would be. Isn't that considered? I don't know.
I think
from previous.
The equation, like the NP is greater than or equal to 10.
Yeah, I saw that, and I was like, okay, but they're talking about P, not P.
So
Okay, this is, yeah.
So if you calculated it like it was just equal to 10, that would be the least you could do, because it has to be greater than or equal to.
Right.
So you just do 10 divided by 1/4.
Yeah, I think
20,
so.
25? I don't know. No. 40?
Yeah.
40? Okay.
That's what I was going to put, yeah.
Okay. I'm glad you saw that, because I was sitting here like, how do you do that? And then, yeah, made more sense now.
Okay, so it'd be 40, right?
Yeah.
Let me write that down for future notes.
Yeah.
P is, or what is the smallest? And that's 5. And we're just using that rule that if NP is greater or equal to 10, and if N parentheses 1 minus P is greater or equal to 10, you can conduct a probability. So.
Yeah.
Okay. So 40. All right. What is the mean of p hat? So it's 0.4 over 24.
No, I think that p hat is.
Is equal to p, correct? The mean of p hat is equal
Oh, that's
to p.
right.
Yeah.
That's right. So it's just 0.4, isn't it?
Yeah, just 0.4.
Okay. Okay, standard deviation. Walker, where did you serve your mission at?
I served in El Salvador.
Oh, yeah? Did you like it?
I loved it over there. It was awesome.
How long ago was that?
I got home like a year and a half ago. Right?
Oh, wow.
Yeah, so it's gone by fast.
Sorry guys, I'm going back to number 7.
Okay.
Do we have to use both? Because, oh, maybe not. Both conditions have to be satisfied. So do we have to make sure that n is more than the other one? Does that make sense? That if you put in like the n that we got for np is greater than 10 or equal to 10, that it's still greater than 10 with the other equation?
Oh, maybe we need to work that then.
So like if you just put in, like we got 40, and then we just put in that into the equation, so the 40 times 1 minus the 1/4, and that's still greater than 10, so it's okay. Because if, sorry, I feel like I'm making this really long.
No.
Okay.
You got it. So you're saying that we need to plug it into that rule.
No, or if we did solve for n for that one, so 1 minus 1 minus the 1/4,
Okay.
and then that looks just like np, so you just 10 divided by that. Yeah. But you get like 13.3 for n. Right?
Okay.
So, but because that's that wouldn't satisfy the requirement, I don't think, in the other equation. So both conditions wouldn't be met if you use that one. Yeah. Because if you did that n into the np is greater than 10, then you get 3, and that's not greater than 10.
I'm sorry, you get what?
You get 3.
3.
0.333. So I guess what I'm just trying to say is I think we need, when you're trying to test for the smallest n, find n in both of the equations, I guess, so that you know which one is actually
Just your answer.
smallest. Because like if we used the other equation instead of the first one, that one wouldn't have satisfied the second requirement. So it has to satisfy both.
Just like,
Okay.
Because in the conditions, it says like if one of them is not satisfied, you can't conclude that it's a normal distribution.
Right. That's what that rule says. It says NP greater than or equal to 10 and...
Yeah, I think I probably just made that like longer and more complicated. But I was just, like went back to check it, so it's just
that's right. Oh, yeah.
okay.
Okay, so calculated. So when I plug in the sample size parentheses 1 minus p, I got 14.4. Is that what you got for that first part? Because in the parentheses it'd be 1 minus 0.4.
Well,
And then
with number
divide by
7,
n.
with number 7, p equals 1/4, which is what I was looking at.
Okay. Oh, I'm looking at number 8. Okay.
Yeah, so with number 7, the p equals 1/4.
Okay.
So you should get 13.3.
So the smallest n that satisfies the requirement is 13.3?
No, it's still 40.
Oh,
Because
okay.
if you put 13 into the other equation, it's too small.
Oh, okay, gotcha.
So I think you're just checking that the n it works with both equations.
Okay.
So you have to solve for n on each of them, and then check it with each of them.
Okay. So that's just for us to remember kind of thing to check
Yeah,
for both.
I think that's how we should do it.
Did you convert that to a decimal?
The 1/4. Yeah, I eventually just did that because it was easier.
Mm-hmm.
Yeah. But yeah, because if you do it with that one and you get the 13, it doesn't fit with the other one. Okay. Should we go back to number 10 then?
Yeah.
Or that's one we're on, right?
I'm on what number am I on? I'm on number 9.
Oh, okay. I must have just put in the answer
The
order.
number 9, what I got was 0.1.
Yeah, that's what I got.
For p hat, the standard deviation. Did everyone else get that?
Yep.
Yep.
So everyone's on 10 now? Okay.
Okay.
Okay, so it says use the following information to answer question 10 to 13. Brittany's batting average is .300. We want to determine the probability she will get more than 35 hits in her next 100 at bats. N equals 100 and P equals 0.3. What is P hat? So that we just have to find the Z score and then put that into no. Sorry, I was
0.3.
Isn't p hat is just the x over n, right? So
yeah.
your x is the number in the sample with the characteristic. So her characteristic that she wants, right? Or is that the 0.3? Or is Or no, she
So
wants
she wants
35 out of 100.
yeah, so that would be 350.
Okay, so
Right?
x is the characteristic, so is it 35 over 100? Is that how you do that?
Yeah.
What is x over, it's x over n for p hat, but, okay, so
Yeah.
it's 35 over n, which is 100.
100.
Okay.
Yeah, so it's just, yeah, see, it's just like your normal, like what you'd think of a probability, which she wants 35 out of 100. So you do 35 over 100.
It would just be 0.35.
Yeah,
Yeah.
that's what I have.
We do p hat.
Okay, standard deviation.
I got what did you guys get for the standard deviation of p hat? I got 0.046.
That's what I got.
Yeah, that's what I got too, 0.0458, but yeah, it's 0.046.
Yeah.
Okay, perfect. And then for number 12, do we just set it up like to find the z-score? Did you do 0.35 minus zero point 0.3 over the standard deviation, which is 0.046?
That's what I did, yeah.
Okay. I just need to put that into. So then for the area, for the z-score, 1.087.
No.
Hold on, I'm not.
No?
Oh, wait. What was. You're saying what the Z score was?
Yeah.
Oh, maybe I think I was looking at the wrong one. What was it again?
1.087.
Okay. Yeah, that's what I got.
Oh, okay.
Sorry, I was looking at the wrong one.
And for the probability, did you get 0.139?
Yep.
Okay, cool. Not 640, 60.
Are you guys ahead of me? I'm sure you are. I'm on number 12. Which one are you guys on?
I'm putting in 15, but I think I'm going ahead.
Okay. So
But
for the area number 12, did you get 0.1387?
Yeah, 1.087.
Yeah.
Yep.
No.
No.
0.1387. What'd you say?
1.087 for number 12.
Well, yeah, for the z score, but when you put in the z-score 1.087, that aren't you supposed to find out the probability of the area?
Yeah.
Or just the z-score? I can't remember. What did it say? Just the z-score. Oh, never mind. Don't mind me. Sorry.
Okay.
1.087. Okay. I was going one step ahead that I didn't need to do.
I think you do on 13. Don't you find the probability? Is that what you're saying?
Well, I haven't even got to 13 yet, but yeah, I guess you would have to do it anyway. So okay.
Yeah. And that one you said 0.138. Is that what you said?
Well, I had it at 6, so now I have it at 0.138. It doesn't matter much, but is that right?
0.139. Is that what you said?
Yeah, 1.39.
Yep.
Okay, I'm on 14 now. Where's everyone?
Yeah, I just barely finished 14, so.
Oh, okay.
Yeah.
Okay. What's the standard deviation?
Hey, Victoria. What did you get for number 14?
0.011.
Okay, yeah, that's what I got. And then 15, did you get negative 1.818?
I got negative 1.791.
Okay, maybe. Did you do for the z-score? Did you do 0.5 minus 0.52 over 0.011?
Yeah. Let me put it in again. Maybe I did something wrong.
Yeah, I got the same thing again. I got negative 1.8.
Okay, so negative 1.80?
818. Yeah, that's what I got.
Yeah.
Are you guys doing number 15 or 14?
15 was that one.
I'm on 14 still.
Okay. So
Oh, cool.
I got negative 1.801. Is that what?
For number 15?
Yeah.
Okay, maybe the reason why I didn't get that is because I didn't do. Okay, I think I know what I did wrong.
I think I heard you guys say 14. You got 0.011. Is that right?
Yes.
0.011. Yeah.
Mm-hmm.
Right.
Okay.
I'm gonna calculate that again real quick to make sure.
Oh, so Victoria, what I just did, I did get negative 1.790.
Okay.
And the reason is because that time I put the whole number in
Okay. Yeah.
instead of just the 0.011.
Mhm.
Okay.
So. Okay. Yeah, that's why I'm putting it in again now, so I have the whole number, because I think that's probably what I did too.
Okay, cool.
Okay. So then you're doing. Okay. What's funny is that I put the 0.0 and I put 3 ones on that last one, and I still had it off by that much or whatever. So.
Yeah, it's interesting. It is very important to do everything, I guess.
Yeah.
Okay, I have a question. For 15, when you set up to find the z-score, what is p-hat? Is it the 50%, 0.50?
Yeah, that's the proportion it's asking about.
Okay. So you're getting a negative number, right? Because that's going to produce a number 0.50 minus 0.52.
Mhm.
That's how you set it up, right? Okay.
Yep.
Okay, and then Victoria, did you get the second choice for number 16?
Yeah.
Where it's the less than.
Less than.
Did you guys get a repeating decimal for 15?
What?
No, I don't
Did
think
you
so.
repeat a repeating decimal? Negative 1.818181818181. Did you get that?
Yeah. So I got that same thing the first time.
Uh-huh.
But if you put in the whole equation for the standard deviation of p hat, then you'll actually get something different.
Really?
Yeah, so that's what happened to me. So you just have to put in the whole equation, or the whole number, I guess you could say. So.
Oh, okay.
So I was just going back for number 12 to check that one, just because we rounded off the decimal in that one too. So I got a little bit different number.
So, but for that z-score, don't we just have to put? Do we have to put the whole equation for that one also, or just like round it off?
I think we're not supposed to round off till the end of equations.
Yeah.
Oh.
And I was
So yeah, I was just putting
gonna
back
put
in.
average.
So I got 1.091 when I put the entire number in.
Okay.
You were changing 12 to 1.091. Okay.
Which will probably change 13 too, huh?
So what did you get? So for the z-score, isn't it 0.35 minus 0.3 over 0.046?
Yeah, but I used the full. I did the standard deviation again and used the full number, so the
Oh.
0.0458257569.
Okay, cool.
So for going back to number 13, then it's 0.137 instead of 1.39.
I think it's 138.
138. Yeah. You
Yeah,
can finally
it's a
run
6.
class. Okay.
Yeah. Good thing we caught those.
Yeah, good job. Oh, so then number 13, what did you get for that?
0.138.
Oh, okay. Okay, I need to put a new z-score in.
All right. Back to 15. So you're saying that you had to work out the whole standard deviation formula again, and then work. Okay.
For 15, you don't. Well, I did the standard deviation and used that number.
Uh-huh.
Do you still have that number up?
Well, I have it as from 14. It's 0.011.
Okay, yeah, you have to use the whole thing.
Okay. Oh, you mean the whole number from that? No, I don't have that out. Okay.
Yeah, so you just do the equation again.
Okay, perfect. And then number 14, we got 0.011, 15, negative 1.790. Right?
Yeah, for
What's
15.
15? What did you guys get?
I got negative 1.790.
Yeah.
790. Okay, that's what I'm trying to get to. Okay.
And then Victoria for so I'm just going to go through those few that we were just updating or editing. So number 10, did you get 0.35?
Yep.
And then 11.046.
Yep.
And then 12, 1.091.
Yep.
And then 13, 0.138.
Mhm.
Okay, cool. And then what did you get for 17? Did you get 0.037?
Yep.
Okay, cool.
Okay, finally got the number for 15. So you guys got negative 1.790. I heard you guys say that.
Yeah.
Hey, and do you know where I would need to send in the little document with what we're all doing?
I think it's under the group project folder.
Because it's like the final project overview. All
Yeah.
it has is mark this activity complete.
Oh, okay.
So maybe I'll just email it to him.
Yeah, that'd probably be good.
I'll put it on the discussion board where we need to put the video, and then I will also put the little, and I'll email it. So.
All right. I think
So
on part of.
Go ahead.
Oh, I was gonna say. I think on part of it says to turn it in like the last week or something too. So I don't know. But I think just emailing it and stuff will work just fine.
Yeah.
So, what were you asking?
I was wondering about 16, how to answer that. What probability could you using normal probability applet? Could you have a big Z and a little z?
Yeah, so this is just like it's just asking the probability of the proportion. So your
Okay.
proportion is your p hat, which was the 0.5 from
Right.
the getting less than 50% of the votes. So your probability is getting less than.
Okay, so it's the first choice then?
The second choice.
Okay, so big Z represents the Z-score and the little z represents the p hat? How you look at that?
I looked at the big Z equals the p hat, because that's how they always had it in the other ones before, was they put the p hat is greater than or less than.
Okay.
Yeah, so on 17, because we're doing less than, we're shading to the left, and
Right. Correct.
so you're going to the left of the z-score, so it'd have to be less than the z-score. So the little z is your z-score.
Okay, so what is probably, okay, so we're shading to the left, you said? So pull that back up. So is the answer the same as our area? 0.137 or 38?
0.037?
Yeah, or 3. Well, because when I shade in the left tail, are you shading the left tail? It doesn't change. It's still the same as when I 13. Did it change for you? Does mine not work?
Yeah, mine changed, because you have a different z-score. So it should change a little bit.
I didn't put in a different z-score. That's my problem. Okay.
Oh, yeah.
So we're putting in 1.790. Okay. Oh, big difference. Okay.
Yeah, and then
So 0.0367 or 0.37?
Yep.
Okay. Okay, make sure I answered them all. Okay, can I go over my numbers really quick from 10 and to the end?
Yeah.
Okay, so p hat is 0.35 for number 10. Then number 11, 0.046. For 12, 1.091, the z-score. 13, 0.138. 14.011. 15, negative 1.790. And then 16 is the second choice, and 17 is 0.037.
Yep.
Okay. Are we ready to submit?
Yeah.
All right.
Okay, perfect. Virtual high five.
Yes.
All right.
So I have one quick question before we all go. For this final project, we said our hypothesis was there's an equal amount of different colored M&Ms.
Uh-huh.
Okay. So I was just, because part of mine is finding the which hypothesis test. So
We didn't discuss alternative, and I'm doing design the study. Do you want me to come up with that on my own, or we can talk about it right now?
we can talk about it real quick.
Yeah. Alternative would be like
Just
if
that.
they're more green or brown
Well,
than, what do you think?
do you want to say that there's